This is Mr. Beck Does Your Homework, AP Physics, Homework 5.1, question number 12. A 4.6 kilogram mass is attached to a light cord that passes over a massless, frictionless pulley. The other end of the cord is attached to a 3.7 kilogram mass. Use conservation of energy to determine the final speed of the first mass after it has fallen, starting from rest, 7.1 meters. The acceleration of gravity is 9.8, answer in meters per second. So what's going to happen is this block will wind up falling down to here, and this block will actually wind up rising up to over here. So beforehand, I've got some potential energy in the first block because it can fall, so I'll call that PE1. This is block 1. And this is block 2. Block 2 can't fall because it's already at the bottom. I'm going to call this 0 at the bottom. So my energy initially is the potential energy in this block, and everything's at rest. The energy is going to equal, afterwards, this block will be up, this block will be down. So this block will have some potential energy. So that's going to be the potential energy of block 2. And as it's rising, this block is going to accelerate down. While this block accelerates up, both blocks will be moving. So I'm going to have some KE for the first block and some KE for the second block. So both blocks are moving. So my total energy before is just potential energy here. My total energy afterwards is a combination of this potential energy and both kinetic energies. So my potential energy for the first block is going to be the mass of the first block times g times the height equals the mass of the second block times g times the height plus 1/2 the mass of the first block times the velocity squared plus 1/2 the mass of the second block times the velocity squared. Now, this block and this block will wind up having the same velocity. So, if I subtract this from both sides, I will get m1 gh minus m2 gh equals 1/2 m1 v squared plus 1/2 m2 v squared. Now, the thing is, you know the masses, you know gravity, you know the height. These heights are going to be the same. But these masses are different, but these velocities are going to be the same. So how do I have this many of this velocity and this many of this velocity? You can combine terms over here. You can actually combine terms over here as well. So if you're smart, you can factor out a GH, and you can have my M1 minus M2 over here times GH equals 1/2 of M1 plus M2 times v squared, which is kind of a neat way to get around. So this is the difference in the masses, this is the addition of the masses. So one's gaining potential energy, one is losing, so that's why I have the difference of the masses, but both masses wind up speeding up. So now it's a matter of plugging in your numbers and solving for your velocity. Love this problem.